Hi, let me tell you about another great Manning book, Grokking AI Algorithms, 2nd edition, written by Rishal Hurbans.
Intelligence remains a mystery, with no agreed-upon definition. Salvador Dali said,
"Intelligence without ambition is a bird without wings."
Einstein believed imagination defines intelligence, while Hawking emphasized adaptation. At a minimum, things that are autonomous yet adaptive are considered intelligent. Living organisms and machines operate on data, visuals, sounds, and measurements. We consume data, process it, and make decisions, so a fundamental understanding of data is crucial for grasping AI algorithms. We loosely define AI as something exhibiting intelligent behavior that helps solve hard problems and provides value. AI includes both systems that simulate natural senses like vision and hearing, and those that leverage language for collaboration and knowledge representation. Additionally, systems that interact with others, learn autonomously, and adapt to new environments also qualify as AI. This definition is constantly evolving. As Douglas Hofstadter noted, AI is whatever hasn't been done yet. Technologies such as a computer adding numbers once seemed intelligent, but are now taken for granted, much like a self-driving car currently seems intelligent because it hasn't yet been perfected. Data is the input to algorithms that perform complex feats. If the data is incorrect, poorly represented, or missing, algorithms perform poorly. Data can be either quantitative, measurable numeric values like temperature, or qualitative, observations like smell or agreement levels. While data should represent unbiased raw facts, humans collect and record it within specific context. AI algorithms simulate how meaningful insights from data become information, and how information combined with experience becomes knowledge. An algorithm is fundamentally a set of instructions and rules for accomplishing a goal. Algorithms accept inputs, progress through varying states, and ultimately produce output. An algorithm can be viewed as a recipe. Given ingredients and tools as inputs, and specific instructions, a meal is the resulting output. AI algorithms are specialized sets of instructions that use data to create systems that exhibit intelligent behavior and solve hard problems. AI tackles distinct problem types, each defined by its context and goal. These include search problems, finding paths to solutions, such as determining the shortest route between cities, optimization problems, seeking good solutions among vast possibilities, like efficient luggage packing. Important. Local best solutions exist within specific areas. Global best is the best in the entire search space. Prediction and classification problems, learning from data patterns, such as predicting fuel consumption or classifying vehicles. And clustering problems, identifying patterns and relationships in data without being asked precise questions. Solutions use deterministic models or inconsistent outputs for specific inputs, or stochastic models return outcomes from possible sets. AI includes various levels of intelligence, which form a foundation for the algorithms used. Artificial narrow intelligence, ANI systems, solve problems only in specific context and cannot transfer understanding to other domains. General intelligence mirrors human learning by drawing from experiences and applying understanding across problems. Superintelligence remains the great unknown, currently existing only as speculation. Old AI involves manually encoded rules. New AI learns from data and creates its own rules that may find patterns humans never would. Search algorithms find optimal paths through evaluation. Biology-inspired algorithms learn from nature. Evolutionary algorithms mimic natural selection. Swarm intelligence shows how simple individuals exhibit collective intelligence through algorithms like ant colony optimization and particle swarm optimization. Machine learning takes statistical approaches differentiated into Supervised learning uses known outcomes. Unsupervised learning uncovers hidden patterns, and reinforcement learning employs reward-based behavior. Deep learning uses many layers of artificial neural networks, where each layer solves specialized problems, contributing to overall solutions for complex challenges like image recognition and language understanding. Finally, we reach the frontier. Generative AI takes deep learning and neural networks a step further. It marks the shift from machines that analyze and understand relationships in existing data to make predictions, to systems that create content, such as writing, code, and images, by deeply understanding massive amounts of rich content, both generally, like language, and specifically, like Shakespeare's poetry. We explore how transformers enable large language models, LLMs, to write with human fluency, and how diffusion models learn to sculpt detailed artwork from random noise. It is the transition from recognizing patterns to generating coherent content from them. AI applications span endless domains. In agriculture, AI optimizes crop growth through pattern recognition in soil and weather data. Banking utilizes it to detect fraud by identifying unusual transaction patterns. Cybersecurity blocks attacks by understanding typical usage behavior. Healthcare assists in diagnosing patients earlier through improved scan analysis. Logistics optimizes routing and vehicle packing. Telecoms optimizes networks based on usage patterns. Games creates adaptive agents that master Go, chess, Atari, and multiplayer games, with research methods applicable across domains. Fitness personalizes health recommendations, and art generation requires a broad understanding to create pieces matching specific styles, like Van Gogh's work. Given AI's transformative potential, there is a great responsibility to build it thoughtfully, with ethics and humanity in mind.
Get this book at Manning.com.